Why are hydrated metal cations Bronsted acids? Well, if we go back to thinking about all those waters being surrounded, all those waters surrounding a metal, we have that picture. I'm going to find it here versus draw a new one. So bear with me as I dig through my stack of pictures. But anyways, you have this copper and he's surrounded by all these waters. Well, if you add a water to him, and I'm going to try and show you that here in a second, that water molecule can actually pluck one of these 12 hydrogens that's out there, so far away from what's going on with all the electrons, can be plucked off by a water molecule, turned into a hydronium ion. So they are able to act like those hydrated metal cations act like Bronsted acids, meaning they are able to donate a proton. A Bronsted acid, remember, donates a proton. So you'll see that picture here when we look at this iron. That's that drawing from a while ago. When a water molecule comes in, another water molecule, not involved in any of this. I'm going to draw them up here at the top. It's going to be a little bit easy. But notice how these hydrogens are kind of ringing all the way around. Oxygens are in here, seeing the great show. Hydrogens are in the back, trying to, see some of those electrons. So this water molecule then, a separate water molecule who didn't make it in time necessarily to actually form a coordinate covalent bond with iron, he still is going to cause some trouble. And he's going to be able to entice this hydrogen to switch teams, or this hydrogen, or this hydrogen, or this hydrogen. Any of the hydrogens around here, it obviously wouldn't matter, is going to be able to switch teams. It's going to make a hydronium ion. This is going to become a hydronium ion. And we're going to be left with this guy as an OH. Oh, I should have gotten that electron and that as an OH, leaving us with a basic, well, I guess we should say we're looking at if this is acting like an acid, water is acting like the base, which is going to make this be the conjugate base, and H3O plus clearly being an acid, being the conjugate acid of this picture. Because that one, why this is H2O5, one of the 6 water molecules lost a hydrogen to another water molecule. Why are anions Bronsted bases? Why do all of our anions act as Bronsted bases? We'll look at that too here quickly. We'll draw the phosphate anion to take a look at why it acts as a, I'll move this guy down since it's in our way, why it acts as a base. The phosphate ion, we're going to have a P, and again, we'll get more into shapes later. We'll use the pretty pink since we're doing P for phosphorus. He's going to have 4 oxygens surrounding him. So an oxygen, an oxygen, an oxygen, an oxygen. And each of those oxygens are going to have another 6 electrons, 3 pairs each. I'll get all those electrons on there. Now, when a water molecule comes in, what actually can happen, we can have a little bit of an equilibrium. That water molecule comes in. We'll use a different color for the water molecule so it's easier to see. That water molecule can come in with his hydrogens, and we can get a bond between those two. In other words, that phosphate ion can accept a hydrogen, accept a proton. And then we end up in an equilibrium situation with a phosphorus, again surrounded by a bunch of oxygens, but one oxygen also attached to an H. You can see that OH group there. We'll put our electrons on just for good measure. And then what's left over from the water, we'll move that up so we can see a little bit better. What's left over from the water? An OH ion. An OH ion being left over. Now, lastly, why are we going to have organic amines? Amines are anything with nitrogen in them, like amino acid. Why do they act as Bronsted and Lewis bases? Well, that's because ammonia is the parent compound of a massive number of compounds that are Bronsted and Lewis bases. If we look at the structure of ammonia, it'll actually explain why. This will actually let you see too where the ammonium ion comes from, how we get the ammonium ion in from ammonia, the gas, where that ammonium ion can come from. So we're going to switch back over, and before I'm not going to come back to this screen, but you can see on page 728 of your textbook that hydrogens can actually be replaced with a huge variety of organic groups. I know those of you who were in Mr. Greenberg's biology, AP biology course went over that in detail with your molecular models, but be replaced with all kinds of things, creating our amino acids among many other compounds. So you have this ammonia with its 2 pairs of electrons. Well, if it's introduced again to a water molecule, we'll use black for a water molecule. It's introduced to a water molecule, and we're going to get an equilibrium going on. We're going to see a bond between that hydrogen, who's not getting all the attention of the electrons from oxygen because electronegativities, and these 2 almost free electrons up here on the nitrogen. And we're going to end up with an NH4, an N with 4 H's all around it. Now, that N gained this extra proton that has a positive charge, but didn't gain any electrons to go with it. So he ends up being positively charged, where what's left over from the water molecule? A hydroxide ion. Now, for the time that's left in class, you all need to really work together. Obviously, you can replay this as many times as you want. Keep watching it over and over, but really work together to go over the day 6 homework. You also have a quiz on Monday, so make sure that you're preparing yourself and teaching each other. We talked about this being a college course. One of the most important things about the fact that it's a college course is that you need to create a community in which you're all helping each other out. Some of this material is a little bit difficult. Some of it you might not have understood. Watching this video multiple times might be helpful for you, or going out and doing your own research or reading the part of your textbook. But use the rest of the class time efficiently. Your homework's due on Monday, so if nothing else, you should be able to finish all your homework assignments in the time you have remaining.